Right after that, slideshow at 5 o'clock.
I'm counting.
Track athletes not going to state.
23. Dude, Eli, come to class on time.
Thursday, PM Thursday, also, library material, you can anime copies. It's the way to start a lot more. All please stand. Please do the flag.
Okay. Reminder, I've already got a pile of kids who are planning on coming in tomorrow morning. Today, Spartan time, advisory. Most of you are just filling out some surveys and then you're good to go. I have the next pile of fresh meat coming in. So my room's locked down for Spartan time today. Yay. And then Thursday I'm not here for Spartan time. So if you have to finish up a test, I've already given people different sets of problems from different forms, just replacement problems. If you didn't finish, that's okay. You just got to find a time to come in. Before or after school is the ticket. You're all in here first hour anyway. Set the alarm half hour earlier. Grab a drive-through on the way in, come in and get it done. Okay? Sorry I'm going to be gone during Spartan time, but crap happens. You actually get today's lesson. Second hour is out in the commons because I am hightailing it out of here in 90 minutes. Boy, this week's a lot. Everyone got the notes? The easiest chapter of the class. Not even kidding. It is formula plug and chug. Okay? This is stuff, it is not going to be hard. This is stuff that you'll see in discrete math. Discrete math and probability is where you start to talk about like all of the when will I use this in real life, pattern recognition, prediction, intelligence testing. That's what this is. In fact, that's where you see most of this kind of stuff. A sequence is a sequence of numbers and they have a pattern to them. So you probably all remember seeing something like fill out the next three in the pattern, right? Pattern recognition is used for intelligence testing, which is biased because it's all normed off of cis het white males and blah, 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 blah. That's a whole different thing. But pattern recognition is used to determine intelligence because it can be used even with non-speaking people. It can be used with non-sentient creatures. You ever heard, like, if humans all died, that dolphins would take over the world kind of thing? Like the smartest animals? They can determine that by pattern recognition. Literally, blue, red, green, blue, red, green. Put keyboard in front of animal. See what happens. Okay, pattern recognition is something that every critter can do. He says to the probably caffeine-deprived group of teenagers. So, a sequence is, what's the pattern? Add 2 every time. That's it. You could fill out the rest of the sequence. Okay? And you'd say it's odd numbers. Okay, what happens when instead I say, let's do 2, now what? Okay, I'm adding successive odd numbers. We should recognize that from all the way back to Algebra 1, x squared plus 1. Perfect square steps, you notice that I don't ever, we've ever graphed a parabola, I don't actually count out the perfect squares, because from the vertex, it's over 1 up 1, over 2 up 4, well, that's 3 more. Over 3 up 9, well, that's 5 more. Over 4 up 16, well, that's 7 more. It goes in successive odds. So pattern recognition really helps us with sequences. They can be finite or infinite. I'm betting you know what those mean. Okay, finite, ends, done. Infinite, puts an ellipsis at the end, goes forever. They can be given in 2 different ways. Explicit and recursive formulas. So recursive formula, let's say I had that. 1, 3, 5, 7, 9. Okay. Let's say that's my sequence. A recursive formula. I did this in Algebra Half earlier this semester. A recursive formula, what's the word that you hear in there? Okay, not cursive. Okay, well, cursive is in there. Recur, meaning again. A recursive formula always says a sub n is, and I tell you what I will do with a sub 1, and then I'll, what do I do to the term that came before it? Well, that's not going to work if I don't have a sub 1. So the format for it is you tell me where to start, and then every number thereafter, I take the number before it and I do stuff. Maybe I'm adding 2 every time. Maybe I'm multiplying by 3/4 every time. Whatever it is. A recursive formula has to be defined on what came before it at every middle child in the room. Okay? How many of you are sick of that comparison to the elder siblings? Okay? So recursive. To do a recursive formula for this, I would say a sub 1 is 1, and a sub n is a sub n minus 1 plus 2. That's the formula. Okay? Now, you see I keep using subscripts. We've talked about them in here before when they've written out polynomials using subscripts. Remember, subscript doesn't have a mathematical operator. It doesn't square it. It doesn't cube it. It doesn't do anything besides just tell you which one. You've seen that for many years. Remember? Remember that? It didn't mean y squared. It meant the second y. So what does this mean? Not just any number, the nth term. So I don't know how far it goes out. That's why we say the nth term. So what is this? The term that came right before it. Example, this is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. Well, if I say a sub n is 9, that's the fifth term. I could write that as a sub n minus 1 or 5 minus 1 or a sub 4 plus 2. The term that came before it. Okay? So this n and n minus 1, it just means the term I'm talking about and the one before that. And then I can keep going in a chain. We get a very, very famous sequence here today with Fibonacci sequence, if you've ever run across that. Okay, Fibonacci sequence, I don't know if we'll have time for the word problem though, because it's long and it's got like branches on the tree and stuff, and I just don't know if we'll have time for it, but it involves a sub n minus 1 and a sub n minus 2. You have to have both. Oh, back up. There we go. Explicit. The first time, like elementary and middle school, that you run across someone's music, it's usually not yours, it's that friend, right? The friend corrupts you. It is explicit content. Warning, parental advisory. Explicit content. What does explicit mean? Direct. Explicit means I don't beat around the bush. I don't say that freshmen are prone to cases of rectocranial inversion. When you think about that, rectocranial inversion.
I always call it
Rectum, cranium, inversion. They got their head up their butt. Okay? So an indirect sentence, a euphemism, would be rectocranial inversion. A explicit sentence would be, you got your head up here. And you just say it. Okay? So an explicit formula is direct. It doesn't beat around the bush, it just goes to answer. If I want the 58th term, I don't need to find the 57 terms that came before it. I can go straight to answer. And for that, you've been doing that for a long time as well. It's just a formula. This is a linear equation. Rate x plus start. What's your rate? What's your rate? What is it increasing or decreasing by every time? 2. So I take 2 times n. I'm always adding 2. The first term, I don't add a 2, 0. And then I add another 2, and then I add another 2, and then I add another 2. So when I'm at the 5th term, I have added 2, 1, 2, 3, 4 times. So in order to find out where I started, since this was a sub 1, we always went back and found, where do I start? You remember this from like algebra half? Rate x plus start. Start is always when x equals 0, y-intercept. When you have the 0th term, but I don't have a 0th term in a sequence, so I have to go backwards. This is the explicit formula. If I want the 5th term of the sequence, n is 5. I would say a sub 5 is 2 times 5 minus 1. Well, there's my 5th term. Lo and behold, it's 9. Okay, so a recursive formula is super easy to write. A sub 1 is this is what I do to my terms. But it's very difficult to find the nth term. What if I said, go find the 391st term? plus 2, 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 plus 2. I'll just take a break now and let you finish that. Or the explicit formula. Maybe a little more difficult to write because you got to think about the algebraic operations, but very easy to find the nth term because it's just wham. Throw in 391 and you're good to go. Okay, so this is all just review of stuff that you probably forgot from yesteryear. Here we go. The bare bones of sequences are, can you tell me what comes next? Can you recognize the pattern? Can you use the formula to create the rest of the terms? So, what are they doing? Add 5 every term, write the next 4 terms. Cool. 22, 27, 32, 37. Yay, I win. Find the next 4 terms of. What are they doing? What they add increases by 2 every time. 3, then 5, then 7. What are they adding? Well, those all happen to be prime, but odds, successive odds. I'm adding the next odd number. So then I'll add 9. Then I'll add 11. Then I'll add 13. What? I said 11. But I added 9. I said it, but I didn't do it. That's like one. Yes, I. Pretty sure I did. Ah, crap. All right. All right. 37, 11, 13, 15, and so on. Okay. First 4 terms of the this. So if I want a sub 1, that means everywhere there's an n, I'm putting 1 like that. Everywhere there was an n, it's 1 because it's the first term of the explicit formula. So 2 times negative 1 to the first is negative 2. A sub 2 is 2 times n, negative 1 to the n. I get 4 times negative 1 squared is positive 1, so 4. A sub 3, what do you think? Everywhere there's an n, now it's 3, because that's my formula. So I get 2 times 3 is 6, and then negative 1 to the third, negative 6. And pretty quick, you start to see the pattern to it. Multiply by negative 2 every time, is what they're saying. Okay? Because every time that you change n up by 1, that means I have another negative, and another negative, and another negative, and another negative. So it's going to keep flipping the sign. And I keep multiplying by more and more and more 2's. So, can you do basic pattern recognition? Are you the worm or the dolphin? All right. I remember 2 from yesterday. What? I remember 2. Fine. Second hour is getting kind of heated.
Really?
No, I just make the mistakes first hour and then I remember them for second. Come on, find the next terms. also caution you, as we're doing sequences, please stick in fraction mode because it's easier than going to decimal town with lots of decimal train. Okay, should be fairly quick. Please tell me you know your cubes. Been banging on that drum since the beginning of Algebra 1. You should know your squares through 20, cubes through 10, fourths through 5, as many powers of 2 and 3 as you can possibly memorize. Quick, what is 2 to the 6th? It is 64. 7 to the 3rd. Yeah. 17 squared. Weak. See, now you're just doing it in your head. It's 289. Okay. So, round 1, what are they doing every time? Division is a lie, and that comes in real hard in this chapter. We don't divide. We multiply by a reciprocal. I am multiplying by a half every time. So times a half, 2, times a half, 1, times a half is a half, times a half is a quarter. Okay. Find the next 4 terms of, what are they doing every time? Add 1, add 2, add 3, add 4, add 5, add 6, add 6, add 7, add 8, 37, add 9, 46, add 10, 56. That's how you're going to get the rest of your brownie points, is I can't do basic arithmetic. All right, the first 4 terms of your sequence given by, so you're going to take your cubes and minus 10. 1 cubed is minus 10. 2 cubed is 8 minus 10. 3 cubed is minus 10. 4 cubed is 64 minus 10. 9 cubed. 729. Okay. So we start with just what is a sequence. And then we're going to talk about that recursively defined. We did it small town. Now, a little bit more oomph to it. The recursively defined sequence is, I hate when they split it up in a line of a sentence like this. A sub 1 is 1. A sub n is A sub n minus 1. That means the term that came before plus 2n minus 1. So, why would they say find the 5th term where n is greater than or equal to 2? Why would they even bother putting that on there? What is n? The line? What? Okay, the order. It's the second term. If they say where n is greater than or equal to 2, they're saying start at the second term. Why would I say start at the second term? I already gave us the first one. Okay, so we have a sub 1 is 1. then a sub 2 will be the previous term plus 2n minus 1. A sub 3 will be the previous term plus 2n minus 1. Why would you do that? A sub 4 is the previous term plus 2n minus 1. And they want the fifth term, previous term plus 2n minus 1. Now, if you got the mental math mojo, you might be able to work through this. If not, when in doubt, write it out. So I know the first term. That means the previous term was 1. N is 2. Write it. So 1 plus 4 minus 1 is 4. The previous term, n is 3. Remember, a sub n minus 1 means the previous term. If n is 3, a sub n minus 1 is a sub 2. Well, a sub 2 is just the thing that came before it. Okay? So a sub n means this guy. A sub n minus 1 means the previous guy. Okay? So I get 4 plus 6 minus 1 is 9. Now, when I say n minus 1 and n is 4, if I stick a 4 here, here, and here, that becomes a sub 4 is a sub 3 plus 2 by 4 minus 1. Well, if I already know what a sub 3 is because it was the previous term, I just plug them in. And I get 9 plus 8 minus 1 is 16. Do we see the pattern yet? A sub 5 is a sub n minus 1, or a sub 4, or 16, plus 2n minus 1. What are they giving us? The squares. Hint, hint. Hint, hint. Recursive formula for squares. Okay, might come in handy. So the idea is, can you follow a formula? Plug and chug. Can you plug these numbers into the formula and find the next terms? Okay? A and B, give them. Get to them, give them a shot. Is now give them. Words smashed together. Like the time I missed entire letters with the algebra class describing someone getting $5. Yeah. Write it out. I attempted to say you borrow $5 and I missed entire letters. And it will forever live in YouTube posterity. And welcome back.
The human span is only 20 minutes.
5 to 7. It's literally 5 to 7.
Custis said it was like less.
That's A, that's wrong. B, he's neurotypical. Alright. Remember, a sub n minus 1 is just code for whatever came before this. Because if I have a sub 8 is stuff, and then I say a sub n minus 1, well, that's 8 minus 1, that's a sub 7, the term that came right before a sub 8. So I start with 3, and then I take negative 2 times the previous term. And then I take negative 2 times the previous term. And then I take negative 2 times the previous term. Times the previous term. Times the previous term. Okay? That's all it means. The previous term. Same for 2b. If a sub n minus 1 goes here when n is 2, 2 minus 1 is 1, a sub 1 is 8. So 16 minus 7. If this is a sub n minus 1 and n is now 3, then 3 minus 1 is 2, so this is a sub 2, which is 9. 18 minus 7. 22 minus 7. Right? 22 minus 7, yeah. 30 minus 7. 46 minus 7. Okay? So a recursive definition is just plug it into the formula, do the thing to the previous term. Now, if you didn't have the formula, if all you saw was that, would you be able to figure out the pattern? Add 2, add 4, add 8, add 16. Now what? 32, then 64, then 128, 256, 512, 1024, 2048, the game that you probably all played, and you should have all of your binary numbers memorized. Pretty sure in the last 10 years, everyone has played that game at least once, even if it was on a friend's phone. So, I'm betting for the top two we're okay. But writing the recursive formula is going to be tough. Writing the recursive and explicit formula. I included these because I think it happens in your homework, but it's not explicitly done in your examples because they expect you to remember this from algebra half. So let's take a little time out to, can you write both recursive and explicit formulas for this? Can you say a sub 1 is this, do this to a sub n minus 1? Can you just go a sub n is formula? Can you write them? Hint, hint, ACT. Aspects of discrete mathematics that may show up on your ACT very heavily rely on this. Think about what are they doing every time? Hi?
So would like a sub 1 be like the first term we
Yep.
get? It would be that.
It would be the very first term. Yep.
Okay.
Now you may have to go back one from that if it's a linear expression or a linear sequence to find the start value. Because start is always at a sub 0, but a sub 0 doesn't exist in the sequence. Okay. Remember, what are they doing? If they keep adding and adding and adding and adding, what is repeated addition simplified to? Instead of saying I added 2 5 times, I'll just take 2 times 5. Repeated addition is multiplication. What is repeated multiplication? No. Exponents. Okay.
It's like exponent to exponent.
I don't know if that has a special term. I just called it exponents. But an exponent to an exponent is one of the few ways you can break your calculator. It was an example of a magic mathematical puzzle. What's the most damage you can do with 3 cards that doesn't go infinite? And it was a double exponential that broke a calculator. An exponent to an exponent. It was 26, what was it? 13 to the 26th to the 26th. Yeah. It's one of the few ways to cause an overflow error to a calculator. Said recursive is should be really easy to write. my recursive formula, a sub 1 is negative 4, duh. A sub n is a sub n minus 1, the term that came before it, and what do I do to it? I added 3, I added 5, I added 7. I'm adding successive odds. Where have we seen this before? In the last 10 minutes. The squares thing. Remember, the squares thing said, what was it, a sub n minus 1 plus 2n minus 1? It was something like that. So if I take that and try to modify it to start at negative 4 instead, well, take the term before it and add, I'll just try 2n minus 1. I'll just throw that on there and see if it works and if I need to modify it at all. So can I take the previous term plus 2 times 2, second term, 4, minus 1 to get this? Is previous term plus 2 by 2 minus 1 equal to negative 1? Yeah. See if it keeps working. Previous term, negative 1, plus 2 by 3, because now it's the third term. So negative 1 plus 6 minus 1. It works. That's why I told you to write this down. This is successive odds. Okay? I told you to write that down because if you ever see successive odds, if you ever see squares, it's going to be this form. The explicit formula, on the other hand, well, we said it's something about squares. So let's say my explicit formula is a sub n is something with n squared. Let's just start there because I know it's squares. Well, if I take 1 squared, I get 1. How do I turn that into a negative 4? How do I go from 1 to negative 4? Okay, write it out as a table. If n is 1, 2, 3, 4, and n squared is 1, 4, 9, 16, but the terms that I had were negative 4, negative 1, 4, 11, you subtracted 5 every time. So that's your explicit formula, n squared minus 5. But you're not going to think of this unless you recognize adding successive odds is a series of squares. That's why I'm trying to stress that is it's something we tried to tell you back in Algebra 1, I mentioned again in Algebra 2, said it again when we reviewed parabolas and polynomials in PreCalc, but no one was paying attention because they're just like, yeah, square numbers. Put it in a calculator, graph by points. Okay. The other one, I start with my recursive. A sub 1, why is it capitalized now? A sub 1 is 1/2. A sub n is a sub n minus 1. What do I keep doing to it? Times 3, right? Because the denominator never changed. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. So I just keep multiplying the previous term by 3. Ta-da! There's my recursive formula. My explicit formula. I want to go straight to answer. So what is it called when you repeatedly multiply? Exponents. What am I repeatedly multiplying? So I'm going to have 3 to the n as my starting point. I repeatedly multiply 3's. Okay, where did I start? And check it. If I say n is 1, 2, 3, 4, and I say 3 to the n is 3, 9, 27, 81. If I say 1/2, 3 to the n is 3 halves, 9 halves, 27 halves, 81 halves. It doesn't match up with what I've got. So how do I change my formula? How do I change my formula to say what I have as my first term is actually supposed to be my second term? What I have as my second term is actually supposed to be my third term. How do I translate everything to the right? 1 minus 1, a sub n minus 1. Yo, this is an exponential function. This is y equals a times b to the x minus h plus k. It's just an exponential function. Okay? Which is some of the stuff that we'll get to. I think it's actually 10.4, the part I cut out. That all of our functions can be represented as sequences if you look at them as finite instead of infinite. All right. Pause. We'll come back to it if we have time. It's really cool. We'll come back to it if we have time. Okay. Convergent and divergent sequences. What is the difference between convergent and divergent besides a really bad teen romance? If you've ever read the books or seen the movies. Dear God. I love you. No, I love you more. Let's go shoot people, but I love you. Yeah. God, I hate those books. Anyway, what does it mean to actually converge or diverge? Converge is the Rolling Stones song, Come Together. Right now. Over me. Divergent, on the other hand. I was just hoping someone would catch it, because every reference I make, you're all like... Yes, it is the Beatles. No. Every reference I make, no one gets it, besides like those two. And that's probably because their parents are old. Okay? Anyway, to converge means it actually, as I go to infinity, my values will converge to a specific value. Remember end behavior? Limit as I approach infinity is a particular number. That's convergent. In fact, you might want to write that next to convergent and divergent. Convergent means the limit of my sequence, so maybe I'll say a sub n, as n approaches infinity is an actual number. Not infinity, not negative infinity, not it alternates between stuff, not whatever, but it converges to a very specific number. Divergent is anything that's not that. Okay? I think so. So, if I want to know if something is convergent or divergent, I'm going to look at what are its values doing. If I want the first term, stick a 1 in there. What do you get? A sub 1 is. A sub 2 is. A sub 3 is. Okay? 9. All right, stick a 2 in there. What's the second term? 6. Stick a 3 in there. What's the third term? Fourth term. Fifth term. Sixth term. Is this sequence going to converge to a specific number? No. It's going to go down to negative infinity. It's just going to keep going. So this would be divergent. How we make a story that makes a teenage white girl feel like she's special. She's different. Then, next one, start at 36. Look at what it's saying. I take negative 1/2 times the previous term. So take this times negative 1/2. Take that times negative 1/2. Take that times negative 1/2. Use fractions. Take that times negative 1/2. Take that times negative 1/2. Negative 1/2. Negative 1/2. What happens as I go out to infinity? It does keep flipping back and forth between positive, negative, positive, negative, positive, negative, positive, negative. But if I were to graph it, it starts up at 36, 18, 9, 9 halves, 9 fourths, 9 sixteenths, 9 32nds, 9 64ths, 9. Eventually, it will converge at 0. So you write that. This is convergent, and I'll even say to 0. Correct. As long as it converges to a number, it's convergent. Anything else, divergent. Hi.
Is there a situation where we know it's convergent but not where?
Isn't it kind of like the limit?
Yeah, it's the limit. It's the end behavior. So can you think of functions where we could not find an end behavior? Like where the end behavior was a number, but I didn't know what the number was. How did we find end behavior of functions that were weird? Spam 9s, right? You go to that table and you throw in 9, enter, and it would say either a number because it converged to that number, or it would have really big positive or negative scientific notation, meaning positive or negative infinity. So I don't know that you can have that. I might have known, but I forgot it because I literally haven't done those classes as long as you've been alive. So here we go. Try to write it out. Stick a 1 in there. Let's see how good your mental math mojo is. Stick a 1 in there. Negative 1 times 1 over 4 plus 1. Negative 1/5. Stick a 2 in there. See what happens. It is 2/9. Do it again. Stick a 3 in there. I'm trying to ignore it. So you see what's happening, right? The numerator is alternating 1, -2, 3, -4, 5, -6. Okay. Oh, other way around. I got my negative swapped. So 4, stop it. -5, 6, -7, 8. And what's happening to the denominator? Well, it's going up by 4 every time because that's the rate of that linear expression. So 17, 21, 25, 29, 33. So how do I know if this is convergent or divergent? Because it's positive, negative, positive, negative, positive, negative. Is it converging down to 0 like the previous one? When in doubt, alpha y equals thing. I've got a parenthesis -1 parenthesis to the, I'll have to call it x instead of n, right? Yeah. Times n, but I'll call it an x instead, over 4x instead of n plus 1. Okay, zoom standard. Okay. Where did it go? You probably can't see it up there, but it's little yellow dots. Let's turn that into something a little bit easier to see. Let's say my 1001st term. But look, really look at those numbers. 2000th term. 2001 term. Not just 1/4. It's going to positive 1/4 and negative 1/4. Are they converging to the same number? No. They're going to both positive and negative 1/4, and that is not the same number, so that one is divergent as well. Now, and that's where you couldn't say, okay, this would be the closest I can think of to Finn's example. Is there something where we know its end behavior or we know its limit but not the number? Well, this is, I know the numbers, but I can't say that's the end behavior because as I go out to infinity, well, is that positive or negative? As I go to infinity, is that odd or even? If I go to infinity and then do the little kid thing of infinity plus 1, doesn't that change positive to negative, positive to negative, positive to negative? So I can't actually say what the end behavior is, which is why it's divergent. A, B, and C. Convergent or divergent? If it is convergent, tell me to what? Okay, what happens to my sequence the further I go out? What if I go out to 100 terms? To the 1000th term? Double check. What if I go to the 1001st term? Like that last one. Okay. If you continue to divide something by a bigger and bigger and bigger and bigger and bigger number, well, I've got like 18 pizzas here. Yeah, I can feed a lot of people. Bring them on. And then 50 kids show up. And then 100 kids show up. And then all 800 kids in the school show up. America. Okay. What happens as you divide a finite resource like 64 over an increasingly large number? Eventually, it becomes 0. Think of n as the number of cuts that I cut something in half. Okay? We chuck Caden up in the air, and we start fruit ninjaing him. And I pause him in place. He never actually hits the ground. I just stand there for the next 2 hours just chopping. Eventually, that number converges to 0. We get Caden soup. Okay? Eventually. So this one is convergent to 0. The next one, it's just a linear equation. I take the thing before it and add 4, and the thing before it and add 4, and the thing before it and add 4. If you get 4 more, 4 more, 4 more, 4 more, 4 more, every single time, it goes to infinity. So that one's divergent. And for C, I take 3 times a negative 1, then 3 times a positive 1, then 3 times a negative 1, times a positive, times a negative, times a positive, times a negative. It's never going to be anything different than 3, negative 3, 3, negative 3, 3, negative 3. Does it converge to a number? So that one is also divergent. Okay? So just a little bit of vocabulary. Probably the next time you'll see convergent divergent series is A, it's a grab bag answer on ACT, or probably in like discrete mathematics after Calc 3. It depends how far you're going. Okay, so I am very guilty of this. Sometimes we accidentally will exchange words. We will use words interchangeably that aren't actually interchangeable. Okay, what is this? A thumb. Isn't it also a finger? Therefore, this is a thumb. But this is a thumb, so that's a thumb. So that's a thumb. So that's a thumb. Right? It doesn't make sense. I had an argument for 6 straight miles with my 4-year-old yesterday that spiders do not have 7 legs. He was adamant because insects have 6. Spiders have more, so they have 7. Like, no, dude, they have 8. My teacher said no, just okay. So I am guilty of exchanging words that are not supposed to be exchanged, and this is one that we have to be careful about. I sometimes will say series instead of sequence, and sequence instead of series, and they are different. A sequence is just a list of numbers. A series is when you actually add up those numbers. And I sometimes will say series when I'm talking about a sequence, and I will sometimes say sequence when I'm talking about a series, and I really need to fix that.
So is this like a drama?
Yes. Yes. Okay. Now.
You're gonna fix it. Yeah. You need to be held accountable.
You're getting called out right now.
That's fair. I've been put on the list of shame before by classes. So, all right. Let's do this. Okay. Again, sequence, just list, series, add together list. Now we're going to start talking about sums. When I talk about the nth partial sum, that means I will take a sequence and I will add together its series up to the nth term. So if I want the, up here, hey, Frank, come on. If I say find the 4th partial sum of this series, that means take the first 4 terms and add them. That's it. That's all it means. But doesn't that mean that you have to find the 4 terms? So if they only give you a formula, you got to go find the terms to add them up. The 4th partial sum can be written like this. S sub 4. Big S sub 4 means 4th partial sum. Or we get Greek on it, and we instead say sigma. Sigma is a Greek S. Now, just like someone else looking at the Roman alphabet might say a Q and a Q, lowercase and uppercase, look nothing alike. A little sigma and a big sigma don't look that much alike. All right. Where have we seen little sigma before? Standard deviation. Little O with a hairdo, right? Okay, it's like Elvis with the little curly Q. Okay. Or Luca. Okay. Well, that's bigger. That's more like Alberto. He's got the things sticking out of his head. Okay. So sigma is just capital Greek S. All it means is add them up. The way that I notate it is I say, where do I start? Add them up until where do I end? Okay? That's all it is. Sigma notation says add up this term through this term for thing. It's very simple if you know what sigma means. If you recently took an ACT, you may have seen sigma on there and had no idea what it meant. That sucks. Especially if it's the thing that gets you a 35 out of 36 and then you end up $35,000 in student loan debt. So, I was banking on my ACT, so I was lazy and didn't apply for a lot of scholarships. Well, I got 35 twice, one wrong in math, one wrong in English. And that was back, the super score that you all get, that just happened in the last like 4 years. So, womp, womp, womp. So, find the fourth partial sum of the thing. If I want the fourth partial sum, I need to know what? The 4 terms. So what's the first term? Stick a 1 in there. A sub 1 is negative 2 to the first plus 3. Negative 2 to the first plus 3 is uno. Find the second term. Negative 2 to the second plus 3 is 7. A sub 3 is negative 2 to the third plus 3 is negative 5. A sub 4 is negative 2 to the fourth plus 3. $19. S sub 4, or fourth partial sum, just means add those up. Okay. Y'all remember compatible numbers? Add the 19 and the 1 first. Add the 7 and the negative 5 first, or second. Then take those two things and add them together.
Is there like calculator for shortcuts for all
So, S sub 3, I've got 4 over 10 to the first. I will not reduce this. There's a reason. S sub 3 says find the first 3 terms. Here's the first term, 4 over 10 to the second. Put a 3 in there for the third term, 4 over 10 to the third. Why would I not reduce these? Oh, you get the same thing. Okay, common denominators is easier. I'll go further. What's another way to write 4/10? What's another way to write 4/100? 0.04. 4,000ths. Because, in this case, when I'm using 10 to the nth as a denominator, I'm effectively saying place values. Okay. So, those are partial sums. Get them.
students who you just did
Remember, part A, they gave me a sub 1. Don't start at a half and go down from there. Okay, you find your first 6 terms. Add them up. 4 times 15 is 60 plus 3. I passed 3rd grade. So as soon as we give you calculators in middle school, kids just fractions, I don't know. Like they
And the arithmetic trackers on the board up there. Yeah. How's that working out for you?
That was pretty good. Shot through the heart, and you're to blame.
Well, I thought about it. 5 seconds ago, and I was like, how is he gonna react? And I was like,
Because 7th partial sum isn't that 3 tenths, 3 hundredths, 3 thousandths, 3 10,000ths, 3 100,000ths, 3. Does it go to millions? Millions? It's 7 of the 0.3 with more and more zeros. So 0.73s, and that's it. I'm gonna be thinking about that all day. That was good. Got me. Okay, and then sigma notation is do the same thing. If I say sigma n sub 1 through 5, that means find the first term through the 5th term, add them up. That's all it means. But if we didn't know what that symbol was and saw it on ACT because we forgot and then reviewed it the very next week in Calc 2, we'd be sad. Put a 1 in there. I get 4 minus 3. Yay. Put a 2 in there. I get 8 minus 3. Put a 3 in there. I get 12 minus 3. Put a 4 in there. I get 16 minus 3. Or now I start to see the pattern. Aren't I just adding 4 every time? Because that's my rate. And this is the 5th partial sum from 1 through 5. So I will add up those 5 terms. Again, compatible terms, 30, 40, 5. Okay. Where sigma notation comes in really handy, though, is sometimes I don't care about the first term or the second term. Sometimes I want to start at the 3rd term and then add them up. Maybe I want to know what the total prize pool is of everyone besides 1st and 2nd place because I know I'll never get there. Okay? I'm bad at magic. What can you say? So I'm going to start with the 3rd term instead. Stick a 3 in there. 18 minus 3 is 15, 15 halves. I'm going to stick a 4 in there. 6 by 4 is 24. 24 minus 3 is 21, 21 halves. I'm going to stick 5 in there. And a 6 in there. And a 7 in there. Let's see if we notice the pattern. Linear expression on the numerator. The rate is 6, so I will add 6 every time. 27 halves, 33 halves, 39 halves. Add all those together. Again, if you use compatible numbers like 27 and 33 makes 50. 60. 39, right? 39 and 21 also makes 60. So 60 and 60 is 120 plus another one is 135 over 2. It's just a mental math trick, which sometimes we need because we can't mental math. And then, word hard, me math good, sometime. Ruh-roh, Raggy. Do you remember this from Chapter 0, Section 1, talking about our different number sets when I have a repeated decimal? How do I turn it into a fraction? How many nines the digit is repeating. Since there is a single 7 that is repeating, I put it over a single digit of 9 and reduce if possible. That's it. So if that was 0.18181818, I would put a 1 and an 8 over a 9 and a 9 and reduce it. And every year I get kids come up to Algebra 2 and PreCalc and I talk about that with number sets and it blows their mind like they've never seen it in middle school. All right, sigma notation, go. Not only do I have a calculator, I have a free graphing calculator app. Mom.
Mom stopped helping me with math in like 7th grade because she'd look at it and be like, I don't know how to do this.
It was a Billingville stand-up bit. When they start putting letters with it.
Yeah, she went to a small metropolitan school in the 70s and 80s, so they didn't have fast teachers. My mom, I can't math. And then my dad.
All right, plug them in, figure it out.
I'm noting that it tends to filter down to the low. 99, it tends to overflow. If you set this up or down on like the pressure one, it tends to overflow. So yeah, you literally just can't go 100 in the sky. Maybe see another reason why irrational numbers are irrational because they can't be constructed in summation.
And that is the premise behind the introduction to discrete math in college.
you have to get the location changes every once in a while.
Discrete means a very particular instance. Discrete math is when you're talking about the laws of counting, the laws of objects occurring. If I have a town with this many bridges, how many different ways can I get across the town? That's discrete math.
This many.
Okay,
How many
ruh-roh.
ways can I get around them?
All right, I am not attempting that by mental math. I can do 343 minus 49. I can do 576 minus 64. I can do 729 minus 81. I can do 1,000 minus 100. I can do 1331 minus 121. And after that, I lost it. I don't know my cubes to 12 and beyond. I said know your cubes through 10. Okay. So a sub 1, or 7, a sub 8, a sub 9, a sub 10, a sub 11, a sub 12, a sub 13. Okay, I'm not really sure what those are. I'm assuming you know how to use a calculator. 6C. What is it? 2/3. Remember, this is a bunch of repeating 6s. 6 is the thing that's repeating, so you put 6 over a single digit of 9, reduce it. And then for B, I'm assuming that you can press buttons on a calculator. Question? What?
8 cubed is 512.
Let's go.
No, it still doesn't work. Crap. I tried to mental math, it didn't work.
What's your arithmetic again? Did you pass the first
That's like fourth.
You signed up to be my TA. I will make you do laundry.